So today what we're going to talk about is points, lines, and planes. So this is the first thing that we really have to get into. It's a lot of definitions, so just bear with me in this section once we get through the different things, because we have to know some key concepts. These are the core concepts right here. These are the undefined terms that we will use. So if you look at this, you have a point, and a point has no dimension. We all know what a point is. It's a dot that represents, a dot will represent a point. So if you look at this right here, you see this right here. That is what a point is. That's what you'll see when you need to draw it. So, and if you were to name this point, if I asked you to name it, you'd just say it's point A. Very straightforward stuff. The next thing is a line. We've seen lines all the times, and a line is one dimension. It is represented by a line with two arrowheads, but extends without end. So if you look at this, you must have these arrowheads. If you don't have these arrowheads, then it's not a line. What these arrowheads mean is that this line will continue to go and go and go and go all the way this way. And the same thing with this arrowhead right here, will continue to go all the way this way. Then you might ask, well, how do you name a line? There's actually a bunch of different ways you can do it. If you notice that this says, this is an L right here, so if I asked you what this line was, you could just say it's line L. Or if you notice there's two points on this line, and you need 2 points, because that's by definition, so you could call it line AB, or simply you can just write out AB with your arrowheads on top of it. So you could write it as AB, and then you want to put the arrow on top of it like that. So that's, and you could also go the other direction. You could also go and say line BA. So it's the same exact thing. They both mean the same. Now the next one is a plane. A plane has 2 dimensions. It is represented by a shape that looks like a floor or a wall, but extends without end. And what that means is it's the same thing as a line, but it almost looks like a floor or a piece of paper. That means that this side continues to go all the way this way. This side continues to go all the way that way. This side continues that way. And then this side continues down this way. Through any 3 points not on the same plane, there is exactly one plane. You can use 3 points that are not all on the same line to name a plane. So if you notice, these aren't on the same. This would make a line, okay, and this one's off of it. So if these 2 are on the same line, you'd have to have another point to have a plane. Now, the different ways to name this, they'll always give you a letter in the corner. Not always, but most of the time. And what that means is that's how you name it, plane M. Or you could pick 3 points that are not on the same line. So, or you could call it plane ABC. Okay, so after going over those definitions that we did, I want to show you an example. So this would be an example of how we know how to use these points, lines, and planes. So in example 1 here, it says give 2 other names for PQ and plane R. So go ahead and see if you can figure that out. Pause the video and see if you can figure that out. Take a few seconds to figure that out. So hopefully if you look at this, if you look at PQ, we all know that PQ is right here. The first thing I would say, how I would name that for A would be line N. Or you could also look at it as line QP. Then let's look at plane R. Alright, so now if we look at plane R, there's many different ways you could name this. So you might have different than what I have, but other names for plane R, I would say the first one that I would look at is plane, because all we need is 3, plane SVT. So if you notice, SVT are not collinear, but they're coplanar. Okay, so that would be one. Also, another way you could name it is plane, let me think, plane PTV. So if you look at where that is, PTV, you notice they're not on the same plane. So that will work. Okay? So that is an example of how you will use these. So that's part A. Now let's go ahead and look at part B. Part B It says name 3 points that are not collinear. Well, first you have to know what collinear is. What is collinear? And that's something we have not talked about. So what collinear means that you have points that line the same plane. So something that is collinear would be S and T. Do you notice they fall on the same line? That would be a collinear point. These would be collinear points. Now another set would be Q and P because they lie on the same line. Okay. The next thing they need to know is what a coplanar points are. These are points that line the same plane. So if you notice, we have this full plane right here. Well, what points lie on that? You need 3 of them. So this would be coplanar. SVP, TVP would be also a set. So those are two definitions I just need. Just think of if you think of coworker, that's someone that you work with. So collinear means it's on the same line. Same thing with coplanar, on the same plane. So let's go back to B. It says name 3 points that are collinear. Name 4 points that are coplanar. So name 3 points that are collinear. I would look at this and I would say that 3 points that are collinear would definitely be S, P, and T. Those would all be collinear because they're on the same line. Collinear. Also for the coplanar that fall on the same plane, you can really just pick any 4. So it would be S, P, T, and V. So right here we have collinear, and these are coplanar. S, P, V, T. Okay, so the next thing I want to talk about is defined terms. And what defined terms means is you're actually going to use the things that we've talked about previously. It basically involves a point or a line. So if you notice in all the examples down below for the segment and for the segment, ray, or opposite rays, they will all use line AB in points AB. So that's why it's defined, because we're using a line and we're using points. So if I could see if I get my pointer thing to work here, for some reason I was having difficulty earlier, there we go. The first one we're going to talk about is a line segment. Now this is a line segment. It has an endpoint, it has 2 endpoints, endpoint A and B. Now, in 2 ways you can write this. So if you were to write this out, it would be line segment AB or line segment BA. Sorry about my writing, getting used to the stylus. So AB or BA. That's all a segment is. It has 2 endpoints. It's not like a line does not go on forever. Now the next one down here is a ray. Okay? The ray has 1 endpoint and it goes on in one direction. So it keeps going and going and going and going and going that way. So the way you write that is, if I wanted to name that first one, you basically just draw a ray. So whatever you're drawing, make sure you put the little arrowhead on it and say A, B. Okay? That is a ray. Now the next thing down here is an opposite rays. Let me erase this first, get rid of all those. Now opposite rays, if you think about it, you have an endpoint right here. C is your endpoint, and it goes on in this direction. Alright, so you have ray CA. So if I were to write out ray CA, it always, when you write it, it always goes to the right. So CA, and then ray CB, those right there would be opposite rays. So if you looked at it, okay, you look at this is the endpoint, C. Okay, here's my endpoint, and it's going in this direction. And then I have endpoint C and going in this direction. So C and A are opposite rays, and then also collinear. Well, you should think collinear, same line, right? Good. Okay, so here's an example of the terms of the defined terms we just talked about. So name and segment, rays, and opposite rays. So what the first one they want to do is give another name for segment GH. So pause and see if you can come up with one. Okay, now that you're back, hopefully if you look at, you have to find out what the segment is. GH, another way you could name that is HG, but just put the segment above it. So that would be part A. Alright, so let's look at part B. Name all rays with endpoint J. So first you want to find out what endpoint J is. So it looks like there's going to be a lot of them. So this is endpoint, and there's going to be a lot of different rays. If you look at this, it'll be from here to here, from here to here, from here to here, from here to here. So it looks like there's 4 of them, but we have to know how to write those. So let's look at that first one we looked at. It would be ray. The ray always goes to the right, and it's going to be JE. And then you also have JG with the ray going that way. So it depends on how you want to write it. Sometimes I write my letters first, or sometimes I'll write the ray first and then write my letters, or JF. And the last would be ray JH. So that's the first part, name all rays with endpoint J. And then which of these rays are opposite rays? There's actually 2 of them. These 2 right here, let's see if I can change my color. If you look at, remember, opposite rays, ones that go in opposite directions. So JE would be a opposite ray of JF. So JE, so this guy right here, would be an opposite ray of this guy right here. Then if you also look at it, JG and JH would be opposite rays. So if we circle those 2, these 2 would be opposite rays. Okay, so the next thing we want to look at is intersections. Okay, so 2 or more geometric figures intersect when they have 1 or more points in common. The intersection of the figure is the set of points the figures have in common. Some examples of intersections are shown below. So basically I just read that word for word, but what it means is, where do the 2 things intersect? If I have 2 lines, so if I have line N and then I have line M that cross through each other, point A would be the intersection point. Because basically where they cross paths. Now if you look at this one, we have 2 planes. We have this lighter plane here and then this darker plane. Well, where they pass through each other would be line Q. So this is just an example of intersection. So you need to know that term intersection. You need to be familiar with an intersection. It just means where 2 figures cross each other.